Welcome to this explainer. You know, a tiny, almost invisible decimal error in pH calibration? Yeah, that can literally ruin an entire batch of expensive pharmaceuticals or completely compromise a massive environmental study. Honestly, your data is only ever as good as your equipment's accuracy. So today, we're mastering the absolute gold standard of precise chemical measurements, the 3-point pH meter calibration. It's a process that demands a bit of patience and strict attention to detail, so let's jump right in.
Here's our roadmap for today. 1. Preparation and setup. 2. Calibrating with neutral buffer. 3. Calibrating the extremes. 4. Sample measurement. And 5. Proper care and common errors.
Okay, before we even touch a single piece of equipment, we kind of need to understand what a 3-point calibration actually is. Essentially, it means standardizing a digital pH meter using 3 very specific buffer solutions: pH 7.0, 4.0, and 9.2. By testing our meter against a neutral, an acidic, and a basic standard, we're basically proving its accuracy across the entire spectrum. This is exactly what guarantees that our actual sample measurement at the end will be completely trustworthy.
Section 1. Preparation and setup. Equipping for accuracy. So prep is incredibly straightforward, but it is absolutely non-negotiable. You've got to gather your digital pH meter, your 3 specific buffer solutions, so that's the 4.0, the 7.0, and the 9.2, and honestly, plenty of distilled water. Having all of this staged right in front of you before you begin, like a chef's mise en place, prevents you from having to scramble mid-calibration. Because scrambling, that leads to dried-out electrodes and completely flawed data.
The physical care of your equipment starts literally right away. First, switch on the meter and just allow it to stabilize. Then, thoroughly rinse the electrode with your distilled water. Now, pay attention to this crucial part. Gently blot the electrode dry. Notice I said blot. Never, ever rub it. It's a highly delicate glass membrane, right? It's not a magic lamp. Rubbing it creates a static charge that will just totally scramble your readings, so a gentle blot is all you need.
And that brings us to the absolute foundation of our entire process, 7.0.
Section 2. Calibrating with neutral buffer. Establishing the baseline.
So you're going to dip the electrode directly into the neutral pH 7 buffer. Now, why do we always start here? Well, because 7.0 establishes the instrument's electrical 0 point. It aligns the meter perfectly before we stretch it out to those extreme ends. The absolute key here is patience. You must wait for that reading to completely stabilize before confirming and setting the calibration. If you rush this step, every single measurement you take afterwards is going to be inherently flawed.
All right, with our neutral electrical 0 locked in, we pivot to the acidic extreme of our scale, 4.0.
Section 3. Calibrating the extremes, stretching the scale.
Okay, now we repeat that crucial rinse with distilled water, seriously, never skip that, and then dip the probe into the 4.0 buffer. Once again, wait for true stability and lock it in by confirming the calibration. What we're doing here is essentially teaching the digital meter exactly what a strong acid looks like, actively expanding its known parameters.
Next up, we immediately transition to the total opposite side of the spectrum to our final basic calibration point, 9.2.
The routine here remains absolutely consistent. Do not skip the rinse step with distilled water. Once rinsed, carefully place the electrode into the 9.2 buffer to finalize the instrument standardization. Wait for that stable reading, and complete the calibration. By strictly following this exact sequence, neutral, acidic, basic, you've now successfully bracketed the entire pH scale that your samples might possibly fall into.
Section 4. Sample measurement. Putting calibration to work.
This is exactly where all your careful setup actually pays off. You're going to apply the exact same rigorous microroutine we just learned directly to your unknown sample. Rinse the electrode to ensure 0 buffer solution is carried over, immerse it into your sample solution, and once more, wait for a rock-solid reading before recording your data. Because you took the time to do a full 3-point calibration, you can trust this final number implicitly.
Section 5. Proper care and common errors. Protecting your precision.
Okay, so to protect your precision long-term, there are absolute do's and don'ts in the lab. You must rinse between buffers, and you always calibrate before a new measurement session. Conversely, if you skip rinsing between buffers, which by the way causes massive cross-contamination, or if you aggressively rub the electrode dry instead of gently blotting it, you are going to ruin your expensive equipment and your precision will absolutely plummet.
So let's review the whole shebang. The exact sequence is strictly locked. distilled water to rinse and blot, pH 7.0 buffer to dip and stabilize, then the 4.0 buffer, then the 9.2 buffer, and only then your sample solution to record the pH. Altering this sequence literally alters your truth in the lab.
Your measurement is recorded, but the science doesn't just stop because you wrote down a number. Are you actually storing your electrode properly?
The answer is really simple, but it gets constantly overlooked. Never, ever leave the electrode out to dry in the ambient air. Always clean, rinse, and submerge your electrode in its dedicated KCl storage solution. Doing this ensures the delicate glass membrane remains perfectly hydrated and perfectly accurate for your next test. Which kind of leaves me with one final thought for you. If complete precision is the absolute foundation of all scientific discovery, what other routine lab habits might be quietly compromising your life's work? Keep seeking clarity, and thanks for joining me for this explainer.